What's up, everybody? Today we're talking about the ASCE infrastructure report. They do these on all kinds of different sectors, and every once in a while I like to do a podcast on them just to kind of go over the grades that we've received and take a look at the infrastructure as a nation. They issue a grade for all different sectors, and today I just wanted to go over the energy one because that's one I'm actually heavily involved with, and it's always fun to check out the industry that you were actually in, see what grade you got, why you got it. But these are reports that are actually issued every 4 years by the ASCE, and so the next one probably coming up in 2021. These were done back in 2017, but they're still worth going through because, well, I don't think anything's changed. So they need a lot of funding, they need a lot of leadership, and they need these things to be pushed through so that the grades can actually be improved over time. It's a huge undertaking, and I think what the ASCE is trying to do is a good thing so that we can boost the grades in the infrastructure in the United States and really get things going. And throughout the world, I'm sure if there were grades on a lot of stuff, most people think the U.S. is really, really good. But it sounds like the ASCE really wants to push that standard a little higher, and so looking at the grades, they're not good. If C's get degrees, we're well under that. So anyway, it's going to be a good one. It's coming right up. We're going to talk about the energy sector and the grade it received, why it received it, and what we can do to help it. It's coming right up.
Hey, what's going on, everybody? Isaac here with Civil Engineering Academy. I'm here with my daughter, checking out YouTube videos. You know how it is. Hopefully you are safe. Hopefully you're doing well. You know what? I had a bout with coronavirus early October and got over that. That was a fun little journey. There's Chloe. Hi, Chloe. Chloe's joining me today. Today we're talking about the infrastructure report card. This is produced by the ASCE. They do these every 4 years. And what they do is they look at all kinds of different sectors within the United States. That includes bridges, roadway, energy, dams, all kinds of railroad, all kinds of infrastructure. And occasionally I like to highlight a few of these, just to sprinkle them in there. And we need to talk about the grades of our infrastructure because awareness can lead to other things. Really what they're diving for is we need funding for these projects. There's a lot of things going on in government where we might be losing money to fund infrastructure, and we don't want to do that. So we want to make sure we have funding, and we also want to make sure we have good leadership to help these programs move forward so that we can get better scores on the scorecards from ASCE. So what I'm going to do today is we're going to talk about just one particular sector. That is the energy sector. And the reason why I wanted to do that is simply because I'm involved in energy. So that's what I do. It's a good one. So energy sector, I actually started out my journey in civil engineering really in the water world, but then I transitioned into the utility world and started working on transmission structures. So energy, this is something that I relate to, and it'd be fun to talk about these report cards in other sectors, sprinkle them in, throughout the year or whatnot as we kind of do some podcast episodes together. So anyway, we want to talk about this. This is the 2017. This is coming from the 2017 infrastructure report card by the ASCE. Like I said, they do these every 4 years. So if you do the math on that, they should be doing another one in 2021. So probably next year. So anyway, let's dive into it. Today we're talking about the energy report card. This is coming from the infrastructure report card from the ASCE, and it's going to be a good one. So here we go. Energy report card. The energy report card, if you were to guess what our grade was in the United States for energy, what would you grade us as? We actually get a D plus on the energy. And they score that based on the outages that we've had in the United States. So we've had over 3,500 outages reported in 1 year. I bet this grade goes down quite a bit simply because of wildfires that we've had over the last 2 years or so and more, where vegetation has been cleared out and a lot of outages have been related to wildfires. So just as a brief overview of this, much of the United States, the entire energy system really predates the turn of the 20th century, which means we have a really old infrastructure. Most electric transmission distribution lines and transmission lines were created in like the 50s and 60s. And most of these, when they're built, they have a 50-year lifespan. I know this because I'm working in the utility world, and we have poles sometimes that are 100 years old. And that really depends on the climate that you're in. In Utah, we have a drier climate. Usually wood poles do last very, very long. But that just, I don't think we're any different than a lot of other utilities out there. And a lot of people just do not update their stuff because it costs money to update your stuff. That's the truth of it. So anyway, that's kind of where we're at. We've hit our 50-year lifespan, well over it in a lot of places, and really not meeting the grade for that. So they have they've listed here more than 640,000 miles of high voltage transmission lines in the lower 48 states, and they say they are at full capacity. Energy infrastructure is undergoing increased investment, so lots of money is being pumped in to to house the energy demands, especially with electric vehicles that are about to be pumped out the assembly lines here very quickly. They already have been, but we're getting more and more and more. It seems like the utility world is actually becoming the gas station, which is crazy to me. So anyway, they're looking at money that we need to increase the investment to ensure long-term capacity and sustainability. In the year 2015, 40% of additional power generation came from natural gas and renewable systems. I can tell you that number is way, way up for renewables. My own utility has been pumping millions and millions and millions of dollars into solar as well as wind generation. We're going more and more away from the coal, which is probably what everybody's doing, but that's just the nature of the business right now. So there's just a lot to that. But we've also been decommissioning a lot of water dams that have hydroelectric dams that have been producing power and things of that nature, and trying to restore a lot of things. So the way the future really tends to be looking at renewables. Natural gas is a good one as well. But that's just where we're headed. So without greater attention to the aging equipment, what they've said, that this has created really a capacity bottleneck. Not good. Bottlenecks are not good. And increased demands go up, we also have climate impacts. Americans will likely experience longer and more frequent power interruptions, which is not good for anybody because everything we have is electronic these days, and it's frustrating when you have power outages. Imagine power outages for weeks or months or longer. Like, are you prepared for that? Do you have infrastructure? Do you have stuff that you could be prepared for a scenario like that? So electricity is definitely high on the list of things that we need to improve upon, and I think we can do that. And companies are. They're putting a lot of money into infrastructure, but more can be done. You can see what's happening in California with the wildfires. That a lot of those issues have stemmed from the maintenance of their transmission and power lines, their distribution lines, not trimming vegetation that's around those. So, when a spark hits, a lot of that dry stuff just lights up. So you got to make sure that's all taken care of. And then just upgrade your infrastructure and make sure you're meeting clearances, which means you need to go a little higher. Make sure you're meeting code, which is the NESC, National Electric Safety Code, on top of putting in a buffer for construction tolerances, which people should be aware of. All right, next let's talk about capacity and conditions. So near term, the U.S. energy systems are projected to deliver sufficient energy to meet our demands right now. Because consumption fell slightly, not a ton. So they compare that. But in general, the capacity and the trends there are that we need a lot more. Populations are growing, demands are growing, and we've already kind of hit upon that. So to reduce the electric demand, changing delivery costs, and new regulations, including those focused on reducing environmental impact, is really important. We need to have prompted transformations across the sector with growth in natural gas, solar, and wind generation. This list in 2015, 40% of additional power generation came from natural gas and renewable systems. I know that's way up. Fossil fuels and uranium have limited reserves, leaving them unable to meet future power generation and delivery needs, is what they've listed. Electricity and oil and gas deliver via well-maintained wires and pipelines remain the most efficient and safe supply chains. New distribution technologies may play an increased important long-term role, particularly as cities grow in population. So let's just take a look at it. We could dive into oil and gas and those things to deal with energy, but I'm just going to look at electricity is what I want to hit with you. So electricity delivered in the U.S. depends on aging and complex patchwork of systems and power generation facilities. It basically includes transmission and distribution grids. You have transmission, which is taken from basically the power plant, transmits it over long distances with AC power, alternating current, and it's transmission on long towers is how it's transmitted. Long lines that eventually hit substations, and it's transferred into distribution, which is carried to your house or wherever it needs to go. So that's kind of how that power system works. So these are owned by an array of investors. They're publicly owned utilities, independent power producers, and governmental agencies. So there's a wide portfolio of people that own power in the electric sector. So, and while investor-owned utilities make up only 6% of the number of electricity providers, they serve actually almost 70% of all electric customers. So think about that. There's only investor-owned utilities make up only 6% of the number of electricity providers, but they provide almost 70% of power to all customers. So, we need more money involved in there. Put some money back into infrastructure. So like we said, the infrastructure is getting old. Most T&D lines were constructed in the 50s and 60s. They have a 50-year lifespan. They were not originally engineered to meet today's demands, nor were they engineered to meet the severe weather climate that sometimes we are facing, including hurricanes, fire. Now we're designing structures to be able to withstand fires so that they don't burn down. Very high winds. A lot of places we're designing for hurricane-type winds. As a design engineer, we typically design for 90 per hour winds, but in high scenarios, we're up to 110 mile per hour winds and higher. So we're making sure we're designing, we're increasing those weather cases, those loads due to extreme weather events. So weather's getting crazy. So with more than 64,000 miles of high voltage transmission lines across the 3 interconnecting electric transmission grids, you have the East, you have the West, and you have Texas. They have their own kind of big system. So the lower 48's power grid is at full capacity as listed by the ASCE. And they're operating well beyond their design, which we've talked about. Often a single line cannot be taken out of service to perform maintenance, as if they do take it out, you're going to cause a outage to a ton of people. This is a problem. This is why we have to create redundant lines so that you can drop a line, maintain the other line, or do maintenance at the substation. This is something that is not done very often, and it should be. I shouldn't say be done very often. It should be done more. We just sometimes don't. If a line is feeding one direction and there's not 2 lines to a substation, let's say, that's called a radial line. It has one line out there. If it needs to be dropped, you're taking out all those customers to maintain that line. And so they've knocked that as an issue. Okay? You can't perform service on a line. You're taking out a line. That's an issue. So grids operating in Alaska and Hawaii are similarly congested and physically island from the other states, so they can't get power from the other states. They can't share power. They call it wheeling. You can't get power from another location because you're out on an island. So sorry if you're in Hawaii, Alaska, sounds like they have issues there. So as a result of aging infrastructure, severe weather events, and attacks and vandalism, in 2015, Americans experienced a report of over 35,000 or 3,500 outages with an average duration time of about an hour, 50 minutes. So this report is about to get updated in 2021. I'd be very interested in seeing how it compares to the way it was written in 2017, but I imagine that they're actually the same issues. So that's kind of the nature of it. So here's their recommendations to raise the grade. This is how we get out of a D plus situation, out of the ditch. They want us to adopt a federal energy policy that carefully assesses needs and then including alternative energy sources. So look at all the sources for energy so that we can generate that. Provide a clear direction for meeting current and future demands. So do we have a plan for the future growth? Most utilities do have a plan. They have to do projections on where things are headed. So I don't understand why that is an issue, but maybe some utilities need more help. They want us to streamline permitting processes to facilitate prompt construction of critical new transmission lines and natural gas pipelines. Process streamlining must include steps to consider alternative approaches and ensure prudent and safe routing. So that has to do with pipelines. They want us to develop a storm hardening plan, which makes sense. If we're investing in T&D, then we want to make sure that we can withstand storms that are happening, which I've talked about earlier. We want to make sure that if we have very high winds, we have fire events, we have crazy weather, that the lines can still stay standing and we can energize them quickly. More and more what companies are doing, utility world, what they're actually doing is turning off the power in high wind situations. You can see this happening in California. They'll turn off the power when they get a high wind because they don't want to be caught. They don't want to be the issue of any sort of fires or causing a fire. So that kind of sucks because you're going to lose your power during that event, but they're trying to, get ahead of the game. So hopefully with these improvements, we don't have to do that as much. Other things they list: increase new rebuilt distribution lines, minimum design loads for ice, wind, temperature to improve reliability. So make sure you're meeting proper clearances. If you need to boost those clearances, let's do that. Promote usage of remote sensing and inspection technologies. So they want us to be able to inspect these lines better, which definitely makes sense because a lot of these issues with fires are because we haven't been inspecting lines very well. I know where I work, we inspect all of our lines, I think at least once a year. So that requires a lot of effort, a lot of manpower. With drones and such that are happening, the technology is definitely improving on doing inspections, which is always nice and exciting to see. So a few bullet items, and then we'll wrap this up. So they want to implement performance-based regulations that mandate verification of integrity of pipelines as well as transmission lines. We're already doing that in some utilities. They want to promote usage of accepted engineering standards over all overhead T&D lines to help safety and reliability. So at least in my own utility, where we service 6 states, we are combining our efforts with some other utilities that still fall under our main umbrella, and trying to formalize standards on transmission design lines, for clearances for a lot of these safety issues. So it's a something that will always be editing and improving over time. So there you have it. I could dive into more, but we're running out of time, and I just want to make sure to get this out there. So our report card for energy was a D+, which really, really sucks. We need more money. We need more leadership, and by improving these things, we can definitely get this grade up. I'd love to see this around a B. I can't believe it's a D+. That's pretty crazy. There's one last thing I want to read here, but for electricity, including all the infrastructure, the investment gap that they're stating between 2016 and 2025 is listed to be $177 billion. So they're saying we have a gap of $177 billion between 2017 and 2015 in order to get this thing up to par. So funding is an issue, can be an issue. A lot of this stuff, hopefully, if you're owned by a private utility, they're putting money into your infrastructure, but electricity is something that we definitely have to have. We have an old infrastructure with lines being built in the 50s and 60s that still need to be updated, and it's an issue. So, guys, this is what I have for you for this report card, the ASCE report card listed in 2017. There'll be another one coming out in 2021, I'm positive, and that would be fun to compare this one with that one. But this is just one little sliver of all the places that they did. If you want to go check out the infrastructure report, go to infrastructurereportcard.org and be aware of the issues in your own sector. It's always fun to learn about them and see what you can do to help. Whether that's getting more involved in the political arena, voting for candidates that support the things you care about, which includes infrastructure upgrades and things of that nature. Anyway, hopefully you're doing well. And that's going to be our energy report card podcast episode. Hopefully this was informative to you. It was informative to me. Chloe really liked it. She enjoyed her chocolate. She's watching her shows, and she's loving life. So anyway, we had a good time. Thanks for being here, and we'll see you in the next one. Bye. Chloe, what do you think? Thumbs up? Yes, that's a thumbs up. So yes, she agrees with me. Good job, Chloe.
I want to watch YouTube.
You want to watch YouTube video? All right. We got to